Okay, Madam Ocheng, you can continue. You can unmute your mic.
Good afternoon. We are going to go through our exercise on photograph work. I'd ask you to do the assignment. I hope that was done. And the answers are with us here. There are two photographs, 1 and 2. 1, the first question, the type of photograph that we are seeing is ground close-up photograph. The animals have covered the wider part of the photograph. It has measured on the animals, so it is ground close-up photograph. B, the main features that could be seen in this photograph, we have the dairy cattle or cows or simply animals. At the foreground and part of the middle ground. Foreground, middle ground, not background, please. Change that. It is foreground and middle ground where the animals are seen. Then at the background, we are seeing a big or large tree, very big tree at the background. At the background left, we can see huts, houses, or settlements. That is 2 marks. Give yourself what you deserve. Then see, our question was on the part or section or location where these animals are seen. And we can see these cows at the middle and foreground. The breed, that is D now, breed is Ayrshire breed. And it is confusing. I know perhaps some had written Guernsey. There's a very slight difference between Guernsey. Both are brown with some patches of white, but Guernsey has more brown. Ayrshire has pale and white patches on the brown. So it is ash breed. Give yourself marks out of 5 there. Out of 5. Then we check on our second diagram, second photograph rather. Second photograph. When we are drawing a sketch, we need the artistical impression. Then we label or name or mark the features within the rectangle or square going by the orientation. Like this one is a square, is a rectangle. We must give the measurements. We have 9.8 centimeters, 6.7 centimeters, but now because we are on online, the measurements would differ. But let the orientation be exactly what it is. It is a rectangle. You cannot put your orientation on a square. The first question on this was the drawing of the sketch. And I've seen a person, somebody might have seen is a worker, is bending to do some work in the plantation or farm or in the agroforestation. This is agroforestation farm. We can see grass in the foreground. We can see some crops, middle ground there, inside these trees or forest. So those are the main features that I saw. You let me know what you have. And when we are drawing a sketch, please ensure the location of features are in their real positions. That is why we are required to subdivide the photograph into 3 parts horizontally, 3 parts vertically. I'm a poor drawer, but I've really tried, so all of you can do it better than what I've done. B, the type of forest shown. When we look at that forest on the photograph, we are seeing it to be a planted forest, Then C, the last question on the photograph were evidence showing that it is a planted forest. I had 2 evidence. 1, the trees are in rows. They are planted in rows. 2, it's agroforestry being practiced because we are seeing the trees as well as crops in the middle ground. So it is a planted forest. Edwin, how are you?
I'm fine.
Tema.
Can you also say it's a planted forest because the trees are of the same species?
Very good. Thank you for that. The trees are pure stands, same species. That's quite okay. Any other?
Yes.
Yes, somebody else? Please, somebody else with a reaction? Any question?
No.
We are okay. So we move.
Yes.
Anyamaze kwanza, you are in class. Akimie kwanza. So we are going for climate. Tuko sawa? Tuko sawa na photograph, we go for climate. Sawa sawa, we'll start with the introduction. Introduction, then now we move to other areas. Climate, I told everybody to go at least you do a lot of research, you read, you remind yourself of what you did in Form 2.
This was not listening. Climate.
Climate, yes, climate. It is a topic that many students fear, but it must be that oneself decides really to do what is necessary. We have several regions of climate. We must know their locations. We must know their characteristics. And it is not that difficult because under characteristics, we'll be looking for temperature, rainfall mainly, under precipitation, humidity. We go for wind. We go for air pressure. Those are the main things, but commonly temperature and rainfall. Under temperature, we go for the ranges, annual range, diurnal range. So the amounts, it is not that difficult the way many students imagine it is. Location is key because you'll be given a world map or map of Kenya and asked to give the type of climate seen in a given area and give its characteristics. So we must know that we want really to get this information, then it will be okay with us. But if we block completely, we will say it is very difficult and it is a no-go zone. And sometimes questions on climate may save one person. Among the many questions, you may find that the climate question is an easier one. So we can't say it is no-go zone, nothing, no. We must try our level best to go through it and understand. So, introduction of climate. Climate is from weather. So what is weather? Weather refers to the conditions of the atmosphere of a place at a particular time of a short period. Particular time of a short period. That is weather. Conditions of the atmosphere. It could, the elements now that we'll be using to describe weather include temperature, humidity, precipitation, more so rainfall, sunshine, cloud cover, winds, atmospheric pressure. Those are the ones under weather. Then, many times one would say it is windy, it is hot, it is cold, it is humid, it is rainy, shiny, and windy. So those are how we describe weather. Then climate. Climate is now the typical average weather conditions of a place that has been taken over a long period of time, and we must insist on saying how long it is. It is usually 30 to 35 years. And that is why of late we know and we understand that climate has really changed. But we've not adjusted on the figures because it has not taken 30 to 35 years. And because we want to pass the exams, we'll still stick to what was written long time ago, which is not making a lot of sense to us today. Factors influencing climate. Factors influencing climate, they are listed here, 10 of them. Altitude is the height above the sea level, but we'll talk deeper about it. Ocean currents could be warm, could be cold, like Benguela should be cold. The western part of South Africa, we have Benguela currents. They are cold ones. We have warm currents, mainly on the eastern parts of the continent. Eastern parts of the continent, like down there between Australia and South Africa, somewhere down there, we have Agalhas, warm current. Then, okay, under ocean currents, we must give the nature of the ocean current. We don't just talk of ocean currents doing that and that. No, no, no. We must give the nature, whether cold, with their names, or warm. The third one, continentality or distance from the sea or large water body. We all know that water body modifies climate. Therefore, continentality is still number 3. Continentality, it modifies the climate. So what about it? The interior part of the land or continent or land adjacent to the sea. How about it? We'll talk more about it. Then aspect. Generally, we talk about aspect in relation to the side of the mountain that faces the sun. Obviously, that side would be warm. And the opposite is true on the side facing away from the sun. Then latitude. Latitude, we have in relation to north and south of the equator. Equator is the largest latitude, the largest parallel of the latitude where it is bulging. So it gives us indication the nearer or away from the equator, temperature decreases. Away from the equator, 0 degrees, temperature decreases as you move forwards. Then the 6th one, configuration of the coastline. All of this we will talk deeper about them. Configuration of the coastline. Configuration is the alignment, the nature. How is it appearing, the coastline? Some are irregular, some are very regular. So what about climate? Where we have regular, where we have irregular in terms of temperature and mean rainfall. We'll look at it later. Forests, whether planted or natural forests, play a very big role. Evapotranspiration, then we'll get rainfall. They'll break the winds. So they play a lot of roles in determination of climate of a region. 8th, human activities. Human activities, there are many. Some are very positive, others give us negative results. Like when we have large industries in a region, the emissions, the carbon dioxide the halons in the atmosphere from these industries will go along for the global warming, the greenhouse effect that we talk of. Then when man has reforestation, then they are modifying the climate of such regions. When man builds large dams, that will still modify the climate of such regions, the ones that we call microclimate now. The ninth one, prevailing winds and air masses. Prevailing winds. Winds are air in motion. And we know that these winds are usually from high pressure areas to low pressure areas. Air masses are very extensive, very large. Air of same or similar characteristics like temperature and humidity should be the same. And they cover very large areas, as I've said. They are very extensive. Then air masses should also be coming from same topography. If it is from a lowland, it is that. If it is from a highland, it should be that. So that is prevailing winds and air masses. How will this affect or influence climate? The last one, intertropical convergence zone, ITCZ. We did this in Form 1, still repeating it. And I know even from primary, you were taught about it. Therefore, it is in terms of the migration of the overhead sun, north and south of the equator. How is it affecting rainfall in this region, in this tropical region where the winds are converging? So we are going to start from altitude. Altitude. Hello. Hello.
Hello.
Hello.
Yes.
Hello.
So far, okay.
Yes.
Sawa.
Yes.
Sawa, sawa. Then let's continue with the altitude. Let's continue with the altitude. Fine. Altitude. Altitude. We move on. Altitude. Temperature decreases with increase in height above the sea level. At what rate? 6.5 degrees Celsius for a rise of 1,000 meters. When you ascend 1,000 meters, then the rate of temperature is 6.5 or 0.65 per 100 meters of ascent. That is, the higher you go, the cooler it becomes within the troposphere. I don't think anybody would forget about that, the lapse rate that we've been talking about. Then, lower altitudes have a larger column of air that retains a lot of heat Get that right? Higher altitudes have a shorter column of air. They are rarefied, leading to cooling, which lowers temperatures. We are going to use some diagram here. Get it properly. Larger column of air down on the slopes, the lower area. Smaller, narrow column of air, which is rarefied. Rare items. Rarefied is from rare items, whether dust, particles, they are rare, leading to cooling, which lowers temperatures. At higher altitudes, there is cooling and condensation of rising moist air, resulting into precipitation, mainly rainfall. At higher altitude, there is cooling. We also know the higher you go, the cooler it becomes. Then as it continues, the air will condense as it is rising. The moist air will condense, resulting into rainfall. That one we know. Then temperature is higher at lower altitude than at high altitude, as the air is heated from the ground, from below, and not directly from the sun. It comes, hits the ground, and it is retained there for long, not just in the air above the ground. Lastly, lower areas have higher atmospheric pressure caused by the larger column of air, while higher areas have lower atmospheric pressure due to the shorter air column. Yes, let's check on this. We check on this diagram. Take a minute. See the arrows from this barrier, from this hill. On our, we can see heat escapes from the surface more slowly because dense air contains dust. Dust particles are containing air. So it escapes slowly, it's heavier. It cannot move very fast up. Then on top of this mountain, we can see heat rapidly escapes from the surface because it is rarefied air that contains little water vapor and dust. Then the degrees here are just rough estimates. Down on the slopes, down there on the lowland, we have around 30 degrees. And on top of this barrier or hill or mountain, it is 10.5 degrees Celsius. Then we have mentioned that low pressure causes rarefied air. High pressure causes dense air. Hopefully, we are understanding that. We go to the next one, ocean currents. Ocean currents have described that we need to know which ones are cold, which ones are warm, and what they are doing to the adjacent land. So onshore winds blowing over warm ocean current. Onshore, and they are warm. They are blowing over, the winds are onshore. They are blowing over warm ocean currents, are warmed, which causes a warming effect, warming influence to the adjacent land. Blowing from the sea, and they've passed over warm ocean currents. They are blowing wherever the adjacent area, adjacent land will have a warming effect, warming influence from these onshore winds, which have blown from the warm ocean current. 2, onshore winds blowing over warm ocean currents are warmed, which make them absorb more water vapor. They are warm, so they are able to absorb more water vapor, consequently increasing humidity. When they absorb more, humidity in the area has increased, and rainfall in the adjacent coastlands. 3, onshore winds blowing over cold. Mark it right, cold. We were on warm, now it is on cold. Cold ocean currents are cooled, which transfer a cooling effect on the adjacent coastline. Onshore winds, yes, but they are blowing over cold ocean currents. They'll carry the cooling influence, so they'll transfer it to where they are blowing to, which is the adjacent coastland. The last effect, onshore winds, moist onshore winds blowing over cold ocean currents are cooled, resulting in condensation with the rain. They are onshore, they are cold, yes, but they are moist. So they are getting cooled, resulting into condensation with rain falling on the ocean. That rain will fall on the ocean, and little of it or no rainfall to the adjacent coastline. But we will be having some fog forming or mist forming on the coastline. Equally, it leads to aridity or desertification on some other areas. It may lead to aridity or desertification. If this is on the western part of the continent, it will really go for aridity or desertification. And that is why we talk of aridity is mainly natural, causes are natural. Desertification, many of them are human. So the western part, cold ocean currents, not bringing rainfall, will give us aridity if they are not moist. That is for ocean currents. 3, continentality or distance from the sea. This one, all of us, let's go for the last point. We'll start with the last point, which is known to all of us. Generally, places far away from the sea are drier, no influence from the water body, while those near the sea experience high convectional rainfall, not just rainfall, but convectional rainfall. That one we all know. But where we have the temperate lands or temperate regions, where we have the winter and the summer, there's a difference. And we are going now for the number 1 point there. During summer, onshore winds transfer cooling effects from the sea to the land, making coastlands cooler than areas further inland. During summer, onshore winds, I've told you, generally what we have is that our number 4. That is what is there. But however, where we have seasons of winter and summer or temperate regions, the three would happen, and the three are what we have there. During summer, onshore winds. The onshore winds, they transfer the cooling effect from the ocean to the land, making the coastline cooler. Because initially we had talked of sometimes back that the water body keeps a lot of heat than land. So during summer, that is what will happen. During winter, onshore winds transfer a warming effect because it's a bit warmer. Onshore winds will transfer the warming effect from the sea to the land, making coastlands warm. As the winds move further inland into the continent, that is, they are cooled by the cold land, resulting into low temperatures. 3. Onshore winds may cause a lot of rain to fall along the coastal areas throughout the year. Areas further inland receive less rain, especially during summer, as the winds have dropped most moisture at the coastal areas. Please take a minute. Everybody take a minute and go through those. Just a minute. Continentality, still that diagram, you are still thinking on the same. Your eyes on the diagram. Distance from the sea affects temperature. I told you that normally, even in our tropical region, during the night, you'll find that water body, lake or ocean, when the sun has set, the water body, the water will still be warm, but land has got very cold in the night. So this is what we have here. It is affecting the temperature. Sea absorbs heat slowly. And sea loses heat slowly. Land absorbs heat quickly. Land loses heat rapidly or quickly, as fast as possible. So distance from the sea affects temperature. Midsummer temperature conditions in a temperate latitude, that is our A there. B, midwinter temperature conditions in a temperate latitude. The temperatures here are just estimates, approximations. So we can see incoming heat from the sun heating the water body, the cool wind to the land, warm wind because it has kept heat for long, lost it slowly. Warm wind is coming from the sea and giving us a lot of influence in the adjacent land. Coastal region cooled by the sea air. Coastal region warmed by the sea air. Night, day. That is what happens under continentality or distance from the sea. Still under that, areas where their temperatures are greatly influenced by the sea are referred to as maritime, oceanic, or insular climate. I hope you've reminded yourselves on the same. Those areas influenced by remoteness from the sea, that is continentality or interior from the sea, are called continental climate. Water body and the interior. The fourth one, aspect. This one is mainly common in the temperate areas. However, even in the tropical regions, we'll be talking about the windward side, leeward side of the mountains. So aspect in relation to the side of the mountain facing the sun. In the northern hemisphere, this one should never leave our minds. Our brain should just store it completely. In the northern hemisphere of the temperate regions, north-facing slopes are cooler. North-facing slopes are cooler as they do not receive direct sunshine. But south-facing slopes are warmer because they receive direct sunlight. Try to figure that out. In the northern hemisphere, where Yes, we continue. There was a problem somewhere. Msioka. Aspect, still an aspect. Let's move on. Aspect, the way we know it. We are on the second point. In the southern hemisphere, in the temperate regions, north-facing slopes are warmer. North-facing slopes are warmer, while the south-facing slopes are cooler. We are on temperature, which forms base to climate. So get that right. What happens in the northern hemisphere? The northern part of the mountain, the southern part of the mountain. 3, windward slopes receive higher rainfall, higher relief rainfall as they trap moist prevailing winds, which rise through orographic effects. The higher it goes, it rises, cools, condenses, clouds form, and rain falls. But the leeward sides have little or no rainfall due to the rain shadow effects. That one is okay with all of us, but the first two, if one is not very keen, can easily confuse. The last one, windward sides have warm, moist, rising winds, while the leeward sides have descending, warm, dry winds with a drying effect on the lower slopes of the mountain sides. So all this is under aspects. Always talk about temperate lands when we are talking about the temperatures on the northern hemisphere. The southern sides are warmer because they receive sun rays directly. But the northern part of the slopes in the northern hemisphere are cooler or cold. They are not receiving the suns directly. The opposite is true in the southern part. The north-facing slopes are warmer in the southern hemisphere, while the north-facing slopes are cooler in the southern hemisphere. Latitude influences intensity of sunshine, which is higher on the equatorial or tropical areas and less towards the higher latitudes or polar areas. Very, very true. On latitude and the temperature, we know that the distance from the equator is shorter, but towards the poles, it's wider or larger, given the nature of the bulging at the equator. Therefore, it is very intense at the equator, yet it is less intense at the poles. We can also think about the angle of reception. We have acute angle to the poles, and we have the right angle at the equator, giving us intense reception of the sun's rays. Then the area covered, this is a smaller area at the equator and a wider area at the poles. So the smaller it is, the higher intensity. And that is for our number one there. The second point, it influences seasonal variation of rainfall due to apparent changes of the overhead sun that cause shifting of the intertropical convergence zone. Latitude influences seasonal variation of rainfall. We know that the sun migrates north and south of the equator. This is where we have our equinoxes in the global world, equinoxes. So when it keeps shifting positions, and when it is to the north, the northern part would have rainfall. When it shifts to the south, the southern part would have rainfall. So that is how it influences the variation of rainfall. Then the last one, latitude also influences pressure variations as wind pattern over the earth, e.g. January and July. We remember the four phases of the earth during revolution, and we can tell the dates, we can tell the summer solstice, winter solstice, and the equinoxes. Now, where we have the sun facing, usually it will have higher temperatures. Like in January, January is very close to December 22nd. From December, it is going anti-clockwise. So we will be having December, then January. January, it is still winter in the northern hemisphere. That means the sun is on the southern hemisphere. We have high pressure in the northern where temperatures are low, but low pressure in the southern hemisphere where the rays are falling, and therefore winds will be blowing from the northern to the southern hemisphere. Winds blow from high pressure regions to low pressure areas. And in July, remember our 21st of June during summer solstice. That means the northern part is receiving, the rays are directly on the northern part, meaning temperatures will be higher in the northern. The southern is facing away from the sun. When it is facing away, we have low temperatures. The pressure will be high in the southern and lower in the northern. Winds will be moving from the southern to low pressure regions in the northern. So that is all we have for latitude. 6, configuration of the coastline in relation to prevailing winds. Configuration, I told you, is the alignment, the nature, how it is, the ocean or the lake, but mainly we are on the ocean or sea, the coastline. Therefore, it is the shape or alignment of and nature of the coastline, e.g. at Lamu, The coastline is more regular, is straight, more regular, therefore less amount of rainfall. The winds tend to blow parallel. When it is regular, then the winds are blowing parallel to the coast, bringing very little rainfall. While in Mombasa, it is irregular, hence high rainfall since the winds are onshore. The winds are onshore and very direct. So that is the first point. Second point, the alignment or shape of the coastline influences the direction of the prevailing winds. Onshore, on straight or regular coastlines, onshore winds blow parallel to the coast, which reduce rain forming to adjacent coastlands. On straight or regular, the way we've given the example of Lamu, it will give us little rainfall because it is parallel. But on indented or irregular coastlines, onshore winds blow towards the land, causing high rainfall to adjacent coastlands, like our example of Mombasa Island. Forested areas have lower temperatures since trees provide shade, which reduces solar insolation reaching the ground. All of us know that. When it is a thick forest, it's even now worse. It really provides shade, which reduces solar insolation reaching the ground. We are still on climate. 2, forests or trees increase humidity of the atmosphere through evapotranspiration. When they transpire into the atmosphere, cools, condenses, and forms rainfall, forms clouds and rainfalls. So forests, of course, trees form forests, increase humidity in the areas where we have them. 3, forested areas receive a lot of rain because of the high level of evaporation and because trees slow down the speed of rain-bearing winds, causing rainfall or precipitation. That number, slowing down of rain-bearing winds. That means it will give us rise to rainfall in the forested regions. The last point, forested areas receive microclimates. Microclimate, e.g. Congo and Amazon forests receive higher amounts of rainfall than their surrounding areas, which is very, very true. Microclimate is one that is experienced in a smaller area because of perhaps a water body, forested or vegetation like the forest, or it could be because of industrialization, microclimate. So those are the facts about forest as a factor. Human activities, dam construction, agriculture, forestation, reforestation, and development of settlements and industries modify climates of surrounding areas, creating microclimates. Human activities, all that we've mentioned, afforestation, reforestation, building of settlements, industries will modify either negatively or positively. They'll give us the microclimate, one of its own kind in a smaller area, If it is agriculture, a smaller area. If it is afforestation, a smaller area, or reforestation, that is under human activities. The same human activities, the emission of carbon dioxide, chlorofluorocarbons, halogens, and other gases from industries and other human activities interfere with the atmosphere, leading to global warming through greenhouse effects. Those are some of the human activities that would influence climate of a region. Prevailing winds and air masses. Winds and air masses, how are they contributing to the influence or how are they affecting climate? Winds, air masses. Wind is a medium of transfer of heat, and so it influences climate. Warm winds will bring a warming influence to where it is blowing to. And vice versa. Please do not write vice versa in an exam situation. That vice versa should be known. So warm winds will bring a warming influence to where it is blowing, and cold winds will bring a cooling influence or effect to where it is blowing to. 3. Moisture-laden winds cause high rainfall to where they blow over. Moisture-laden or moist winds cause high rainfall to where they are blowing over, or 2. The 4th one, persistent dry winds. Persistent dry winds cause desertification to the areas they blow to. Aridity or desertification to areas they don't have moisture, no rainfall, so they'll cause aridity or desertification. These other local winds like land and sea breezes modify climate of the areas they blow to. We know land breeze and sea breezes. They modify the climate of the areas. We also remember the katabatic and anabatic winds. What is their effect on climate? Katabatic winds may contribute to low night temperatures. Katabatic, the ones that are flowing downwards from a mountain to the valley. So they will contribute to low night temperatures in valleys or lowlands. While anabatic winds may aid in formation of cumulus clouds, which cause afternoon showers in highland regions. Anabatic, the ones now in the daytime, afternoon, rainfall can be caused. Afternoon rainfall showers in the highland regions, very, very common for anabatic winds. The common ones that we've always heard of or talked about, the Fawn, the Chinook. Winds are dry, descending, warm winds which cause dryness of the leeward sides of Alps and Rockies, Alps and Rocky Mountains respectively. So all that is about air masses and winds. The last one Intertropical convergence zone, intertropical convergence zone, intertropical convergence zone. It is a low pressure belt that shifts position according to the overhead position of the sun, north or south of the equator. Northeast and southeast trade winds converge here at the ITCZ, causing places near the equator to have 2 seasons of high rainfall, partly reason for double maxima of rainfall in this area. Like in our country, we used to have, but it is still documented, we've not changed the details of climate. We used to have March to May high rainfall, so we use, that is the first maxima. Then September to November, December, we used to have short rains. That was the second maxima. That is why it was called double maxima in a year, because of these trade winds. Then the last point, places in the northern hemisphere farther away from the equator experience only one rainy season. Places in the north farther away from the equator experience only one rainy season when the sun is overhead in the region, and a long dry season when it shifts to the southern hemisphere. So those are the details about ITCZ. Then quickly, as we ponder what we've gathered under the factors influencing climate, now we come to Kenya's climate. Kenya's climatic regions. There are quite a number, and there we go with those letters M. We go, in fact, we need to have the location at our fingertips, the location of these regions. So we are studying this map of Kenya. Map under the key M, we have modified equatorial climate of the lake basin. Quickly take your eyes on the lake basin where we are seeing Kisumu, that area. The climate experience there is modified equatorial climate of the lake basin. N, modified equatorial climate of the coastal plain. I've said and repeating, location is very key. So we go to where we are seeing N with the Lamu, Malindi, Mombasa along the coast. That is N. P, take your eyes to where P is found. P, tropical northern, okay, nimeipata. P, tropical northern climate along the Uganda border. P. K is very large, it's covering almost half of this country, Kenya. K, tropical continental climate. Tropical continental climate, where we have the K is quite large. Then Q, desert climate of northern Kenya, towards the north, where we have Marsabit, Wajir. L, modified tropical climate of Kenya Islands. L, Take your eyes there. L, modified tropical climate of Kenya highlands. The modifications are due to either the lake, the water body, or highland that modifies. So they're having their own climate beyond the surrounding area because they are modified either by the relief feature, the highlands, or because of the ocean or Lake Victoria. The last one, tropical climate of southern Kenya. Tropical climate of southern Kenya, where we are seeing Taveta, we are seeing Narok. Those are the areas for tropical climate of southern Kenya. So modified tropical climate of Kenya, highlands, subtropical climate is also known that way, subtropical climate or modified tropical climate of Kenya highlands. We have the eastern highlands, we have the western highlands. Therefore, these are the characteristics. Rainfall throughout the year. These regions receive rainfall throughout the year. High rainfall between 1,000 millimeters to 1,500 millimeters annually. Double rainfall maxima. It receives long rains in March to May and short rains between September to December. But single regime on the western highlands from April to August, in particular the Kericho area. Western highlands, it's just single, not double regime on our Kenya highlands. That has to be noted. Then mainly receives relief rainfall with high rainfall of up to 2,000 millimeters on the windward sides and lower on the leeward side. Rainfall mainly caused by southeast trade winds, has warm to hot conditions, that is 17 to 24 degrees Celsius. That qualifies the place to be referred to as warm. When it is 17, we have the key to how to describe climate. So we'll have that table later on. When we talk of 17, it is under warm. When we talk about 24, it is under hot. Cool conditions on high mountains. Then remember, it is the equatorial region but modified. That is why it is hot, yet we are having on the mountains. Lower slopes are warmer than the higher slopes. High temperature is modified by altitude. The higher you go, the cooler it becomes. Then has moderate humidity levels. Moderate humidity levels. Coolest months are July and August, while the rest of the year is warm. Indeed, coolest months of late it is even starting from late May. The whole of June we had very cool environment. July now is still very cool. And this one is quite true. Days are warm while nights are cool or chilly. This is Kenya highlands. Mean annual temperature range is small. It is 3 to 5. 1 to 7, we call it small. So mean annual, the daily temp, mean annual, yearly, our range is between 3 to 5 degrees Celsius. So those are the characteristics. Those are the characteristics of the modified climate of Kenya Highlands or subtropical climate. Please, if you cannot remember the figures properly, then use the description. Like where we are having high rainfall, 1,000 to 1,500 millimeters, we will simply talk of high alone and you'll still score. If you'll not go for the range there and get it, you can still use the word about. If it is somehow coming into your mind, you can still use the word about 1,000 millimeters per year, that one you'll get. But if, for instance, you go for about 1,000 to 1,600 millimeters per year, you will not get because you missed the range. So get used to the descriptive terms, then you'll be much better off. Hello. Victor.
Yeah.
Aurora.
Yes.
Kwa pamoja.
Yes.
Pata ama we are still here.
Yes.
Are we okay? Ni watu. Tuendelee.
Eh,
Tuendelee ama tuachie hapo?
tuachie hapo.
Tuachie hapo, lakini tumeelewa.
Kwisha inaisha. Yes. Kwisha inaisha.
Tumeelewa.
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 Continue.
Yes.
We'll continue next week. Aya, bye. Stay safe.
Bye.
Aya, see you then. God willing.
You too.
Aya.